When medieval bridges still stand on their original timbers and cathedral roofs outlive entire nations, the question is not whether medieval engineers understood rot, but how deeply they understood it. Long before synthetic sealants, pressure treatment or chemical preservatives, builders across Europe developed systems that allowed wood to survive damp ground, driving rain and seasonal humidity for centuries. Their success came from engineering discipline, material science by observation, and a refusal to fight nature blindly. They learned how rot actually works, and then designed structures that made decay biologically impossible. Why medieval builders focused on preventing conditions for rot rather than coating wood. Rot is not caused by water alone. It actually requires sustained moisture, oxygen and organic nutrients held at the right temperature. Medieval engineers understood this even if they did not name the fungi involved. Instead of sealing wood completely, which, traps moisture, they focused on eliminating one of those conditions. Most often they removed time. Wood was allowed to get wet, but never allowed to stay wet. This single insight shaped every design decision that followed. Timber selection really determined the lifespan of a building before construction even began. The type of wood chosen could make all the difference, and, it was a decision not taken lightly. Medieval engineers, with remarkable instinct, rejected fast-grown wood. They just knew somehow that such timber wouldn't stand the test of time. Timber was, more often than not, sourced from old forests, where trees grew slowly, shaped by years of competition for light and space. This slow growth, you see, produced the strong, durable wood so prized by builders of the era. Tight growth rings created dense fibres that absorbed water slowly and released it evenly. Oak, chestnut, larch and pine were chosen for specific environments. Oak resisted ground moisture. Larch thrived in exposed conditions. Chestnut naturally repelled insects. Applying this today means matching species to environment instead of assuming one treatment solves all problems. Seasoning was always treated as a matter of structural preparation, rather than simply a means of storage. It was understood that properly seasoned wood would provide the necessary strength and reliability for construction. Freshly cut timber was never, ever rushed straight into construction. Instead, beams were air-seasoned for years, sometimes even decades, kept under cover but with plenty of ventilation, allowing the wood to mature at its own pace. This slow, patient drying process preserved the internal structure of the wood and, crucially, prevented cracking that could compromise the integrity of the entire building. You see, cracks invite deep moisture intrusion, which honestly no surface coating can stop. Modern builders, they can apply this principle by prioritizing air-dried lumber over kiln-dried stock for exposed or load-bearing applications, even if it requires, longer planning cycles. Here's the thing. Medieval foundations kept wood alive by keeping it dry indirectly. Contrary to modern assumptions, medieval engineers avoided burying wood whenever possible. Posts rested on stone plinths. Sills sat on raised masonry courses. Even when wood touched the ground, it was isolated from constant moisture by gravel beds and drainage trenches. Water was guided away before it reached timber. This approach is still, superior to chemical reliance. Elevation and drainage prevent rot permanently rather than just delaying it temporarily. Why controlled airflow was, carefully engineered into walls, roofs and floors. Medieval buildings really breathed. Their roofs were layered, not sealed tight, and the walls actually allowed vapour to escape. Floors were often raised to permit air movement underneath. Moisture that entered could always leave, and this constant drying cycle, it denied fungi the sustained dampness they need to survive. So, applying this today means, avoiding airtight wraps around structural wood, and instead you want to design cavities that ventilate naturally. Now, charring and surface hardening acted as moisture regulators, not as coatings, which is, honestly, a pretty clever approach. In some regions, medieval builders would lightly char posts and beams that were exposed to weather or ground contact. This was not decorative, by the way. Charring closed surface capillaries, reduced water absorption, and discouraged biological growth while leaving the core breathable. The technique remains effective today for fence posts, garden structures and foundation beams. Light surface charring followed by brushing removes fragile char while retaining protection. Joinery really mattered far more than sealants ever could. In medieval construction, the way pieces of wood were joined together was absolutely crucial for strength and longevity. Medieval joints, interestingly enough, were designed to shed water naturally. This clever approach helped protect the timber and, kept the structures standing for centuries. Mortise and tenon connections? Ah, yes, they allowed the wood to expand and contract without splitting. This ingenious technique made medieval buildings much more resilient over time. Wooden pegs swelled when damp, sealing joints temporarily, then relaxed as wood dried. Metal fasteners, which introduced stress points and corrosion pathways, were minimized. Builders today can dramatically increase wood lifespan by favoring joinery that accommodates movement instead of resisting it. How roof geometry became the first line of rot defense. Steep roof pitches, deep overhangs, and fast-draining surfaces were not, just stylistic choices. They were actually rot prevention systems. By keeping rain off structural timber, medieval engineers reduced moisture exposure more effectively than any surface treatment ever could. Extending eaves and managing runoff remains one of the most overlooked yet powerful preservation strategies available. Why medieval bridges offer the clearest proof. Many medieval bridges used timber piles driven into riverbeds where oxygen was absent. Without oxygen, rot fungi could not survive. These piles remain intact today. This demonstrates that medieval engineers understood environmental control at a biological level. So, modern applications, well, they include submerged foundations, waterlogged environments, and even, garden posts that are placed below oxygen-rich zones, provided that proper design is used. Choose dense, slow-grown timber, that's key. And of course, season it properly. Always elevate wood above ground. It's important to design for drainage and airflow. Use surface hardening techniques like charring where appropriate. Allow wood to move, don't restrict it. And remember, protect from above before sealing from the sides. Accept that maintenance is, part of longevity, not a failure of design. Medieval engineers did not preserve wood by fighting nature. They preserved it by, understanding it. Their methods endure because, honestly, biology has not changed. If this kind of historically grounded knowledge matters to you, do consider subscribing to Ancient Know-How. Share this guide with fellow builders and history enthusiasts, and help keep these proven principles alive where they still belong, in real-world use, not forgotten archives.